Okay, let's take a look at the 3D handout. So the first question is giving you some information about various angles, and you're supposed to use that to determine if any lines are parallel, and then give the reason why. So to review, let's list off the ways to get parallel lines. So we know one way to get parallel lines, if corresponding angles are congruent, then we get parallel lines. Let's see what else. We know if alternate interior angles are congruent, we get parallel lines. If alternate exterior angles are congruent, we get parallel lines. And then the last two were the same side interior angles. If those are supplementary, we get parallel lines. And then the last one is same side exterior angles. If they're supplementary, we get parallel lines. Okay, so there are the main reasons. There's also if the slopes are the same, but these aren't on a graph, so we can't do slopes. Okay, so let's take a look at the picture. And the first one says angle 1 and angle 8 are congruent. So, oh, and by the way, remember to get parallel lines using these angles, to get any of these types of angles, you need exactly 3 lines. You need the 2 that are going to be parallel, and you need the 1 transversal. If for some reason there's only 2 lines involved or 4 lines involved when you're carving out these angles, then they're not going to be any of these types of angles over here, corresponding alternate interior. It's always 3 lines that forms them. Okay? So let's take a look at angle 1. So 1 is formed by these 2 lines. So there's angle 1. And then angle 8 is down here. And we know that they're congruent, so I marked them with 1 curve each. And then if I move this over, hopefully you can tell that 1 and 8 are corresponding angles because they're in, the top left here, top left there. So we know that, let's see, in this case it'd be line A and line B. So we know A is parallel to B because corresponding angles that are congruent give us parallel lines. So I'm going to get rid of this so I can fit that in. Give us parallel lines. Right? Let's take a look at the next one. Angle 12 is formed by these 2 lines. So that's line B and line D. And then angle 7 is formed by line E and line B also. So that's good because it's 3 lines. We know that angle 7 and angle 12 are congruent. And if I slide this over, you might not see it yet, but if I extend this line, hopefully you can kind of see this Z shape right here. Right? And the Z shape is alternate interior angles. Right? They're on opposite sides of the transversal, so they're alternate. And then they're in between the two lines that we're looking at, so they're interior. So 7 and 12 are alternate interior angles. They're congruent, so we get parallel lines. So it's this reason, number 2 over here. So let's see, that's going to be E and D are parallel because alternate interior angles that are congruent give us parallel lines. C. Let's see. Now C involves 3 angles, and we're looking at pairs of angles, so that probably means we need to combine 2 of them. So let's see. 7 is here, formed by E and B. And then 4 and 3 are right next to each other here. So the trick for this problem is actually to think of 4 and 3 as one big angle. So that's this one. And it doesn't say they're congruent. It doesn't say 7 and 4 plus 3 are the same. So I'm not going to mark them both with 1 curve. I'm going to do this one with 2 curves to show that it's a little different. And 4 and 3 put together are formed by E and A, lines E and A. So here's 4 plus 3. Here's angle 7. If I slide this over, well, they're on the same side of the transversal, and they're interior between the two lines that we're looking at. So over here we have same side interior angles. If they're supplementary, which they are because they add up to 180, then we get parallel lines. In this case, it's A and B. So A is parallel to B because same side interior angles that are supplementary give parallel lines. Okay, let's take a look at the next one. It says angle 2 formed by this line and this line. So that's A and C. So angle 2 plus angle 14, which is formed by B and E, are supplementary. They add up to 180. Well, if you look at this, there are 4 different lines involved here. Right? The angles aren't really connected in any real way. So since it involves 4 different lines, this is no parallel lines result. Right? They might equal 180, but that doesn't force any lines to be parallel. Okay. And I'll put in parentheses here a little note. 4 lines involved, not 3. All right, let's see, the next one, 12 plus 11 equals 2. So let's see, here's 12 and 11. So we'll put those together. Because, again, there are 3 angles here. So I'm thinking of this as one angle. And then angle 2 is up here. And 2 is formed by C and A. And 12 plus 11 is formed by C and B. And they're not equal. Oh, no, they are equal. So I can use one curve for each. If you look at it, these are on opposite sides of the transversal, so they're alternate. And they're not interior, right? They're not in here. They're on the outside of the 2 lines. So they're exterior angles. So they're alternate exterior angles, and they're congruent. So that gives us parallel lines. So that's going to be A and B again. A is parallel to B because alternate exterior angles that are congruent give us parallel lines. The next one says 3 is congruent to 8. So angle 3 is formed by these 2 lines, A and C. And it's congruent to angle 8, which is formed by C again and B. So if I slide this down, this was line A, this was line B. They're on opposite sides of the transversal, so they're alternate. And they're inside the 2 main lines, so they're interior. So they're alternate interior angles, and we know they're congruent. So those give us parallel lines, and in this case it's A and B. So A is parallel to B because alternate interior angles that are congruent give us parallel lines. Okay, let's take a look at the next one. 5 and 6 are supplementary. So here's angle 5. Here's angle 6. They're not equal, so I'm going to use different numbers of curves there. 5 is formed by A and E, and 6 is formed by B and E. And if I slide this over, whoops, let me do that again. They're on the same side of the transversal. They're both on the left. They're both inside the 2 lines, so same side interior angles. They're supplementary, and if same side interior angles are supplementary, we do get parallel lines, and in this case it's A and B again. So A would have to be parallel to B because same side interior angles that are supplementary give you parallel lines. All right, so let's look at number 2. Number 2 is a proof, and in number 2 what I've done is we have to prove that we get parallel lines somehow. So that's going to be the last sentence here. BC is parallel to AD And so a reason would have to say, so you get parallel lines. Right? So it's going to be one of these 5 reasons that we've talked about before. The beginning starts with parallel lines. So then the next step is going to be, well, the parallel lines are going to give us something about angles. So it's going to be either angles are congruent or angles are supplementary. And then the reason will be parallel lines give you something. So this is going to be given right here. AB is parallel to CD. So let me mark that. AB is parallel to CD. So I'm going to do the little arrows to mark parallel. Okay. Well, parallel lines give us a bunch of things. And in this case, let's trace out our parallel lines. And in this case, we're looking at these numbered angles. And if I draw in this line, BD, notice that the lines themselves formed angles 1 and 4. They didn't form 2 and 3. 2 and 3 involve these lines right here, which we haven't really dealt with yet. So I've got angle 1, sorry, not 1 and 3, 1 and 4, right? 1 and 4. If I move this over to the side, it might be a little bit easier to see. That's a Z shape, right? Here are my parallel lines. They're interior to the 2 lines, and they're on opposite sides of the transversal. So those are alternate interior angles. Parallel lines give me alternate interior angles that are congruent. So in this case, I'm going to say angle 1 is congruent to angle 4. These parallel lines give me alternate interior angles that are congruent. Okay, so let me come back over here. I'll mark these angles and the parallel lines. Okay, the next step says given. It says angle A is congruent to angle C. Okay, now I'm not going to mark this with 1 curve each because then that would imply that they're the same as angles 1 and 4 also. I'm going to use 2 curves. 2 curves here, 2 curves there. Okay? Now, we just learned a new idea. If 2 angles from one triangle are the same as 2 angles from the other triangle, then the third angles have to match up too. So that means angle 2 and angle 3 have to be the same. And the reason is this one. You can either write out if 2 angles of one triangle are congruent to 2 angles of another, then the third angles are congruent. You can draw a little picture that says this. Right? If these 2 angles in the first triangle are equal to these 2 angles in the second triangle, then the third angles have to be the same too. Okay? Then the last sentence, so at this point we're at 2 and 3 are the same. And the last sentence says BC is parallel to AD. So that's going to come out of this reason, out of this statement. It's got to be related to the step before it. So if you look at BC and AD, here's BC, here's AD. Angles 2 and 3 are formed by those lines and this transversal right here. Here's 2, here's 3. So let me slide this over. And I'll get rid of this other stuff in the way here. Now if you look at 2 and 3, they form that backward Z shape. Those are alternate interior angles. We already know they're congruent. Alternate interior angles that are congruent give us parallel lines. And in this case, those parallel lines were BC and AD. So this is going to be alternate interior angles that are congruent give parallel lines. Okay, I hope that helps a little bit. Let's go on. So this one, I'm just going to start filling in stuff here. So let's see. I've got a 151, and then the angle next to it, we'll have to add up to 180 because this is 180. So let's see. 180 minus 151, it's going to be 29. So this angle on the inside here is going to be 29. Let's see. I've got a triangle here, and I know 29 plus 63 plus y should be 180 because it's a triangle. And if we, let's see, that'll be 92 plus y equals 180. Y ends up being 88. So this one's 88. Notice the parallels, right? If you don't see those, then you can't finish the problem. And right here I can make one of these z's. Remember, the z's are alternate interior angles. So if this one's 29 and the lines are parallel, then that one's 29. So x is 29 degrees. Let's see, what else? We could get this angle over here. You could get it two ways. One way you could get it is by noticing, since the top line and the bottom line are parallel, since that one's 63, if you made this Z shape for alternate interior angles, this one's 63, right there. Which actually, if you look over here at W is going to be a vertical angle with that. So this one's 63. And then Z we could get by doing 180 minus 63. So W 63, 180 minus 63 is Z, which is 117. Okay. By the way, you could also get the W is 63 this way. If you actually look, let me erase this stuff here. If you actually look at the picture, let me erase that. This one's 63, this one's W. If I move this over, the lines are parallel, so the 63 and the W have to be congruent because they're corresponding angles. And we know parallel lines give us corresponding angles that are congruent. Okay, number 4. An equilateral triangle is also equiangular. Okay, well, that means, so equilateral means all sides are equal. And equiangular means all angles are equal. Right? All side length and all angle measurements are the same. So this means if you have a triangle where you know all three sides are the same, then you know that you actually have a triangle where all three angles are the same. Okay. And in fact, you can even figure out, since it's a triangle and it's 180 and all the angles are the same, 180 divided by 3, they're all 60. So you can't figure that out. I don't know how long the sides actually are, but that doesn't really matter for this. So to describe it to a student who hasn't learned these terms, you might say something like a triangle with all three side lengths, all three sides the same length, also has all three angles the same size, let's say. Now it turns out it works both ways. If you have a triangle and you know all three angles are the same, then you actually have a triangle with all three sides the same. So I'll put here and vice versa. Okay, so number 5 says if you have an equilateral triangle, it's always equiangular. And if you have an equiangular triangle, then it's always equilateral. So then the question is that true for quadrilaterals, 4 sides? So one of the questions would be, well, if all 4 sides are the same, does it have to be equiangular? Right? So do all 4 angles have to be the same? Well, let's think about that. If you draw a square, all 4 sides are the same and all 4 angles are the same. So that's an example that would make you think, yeah, this works. But it's not generally true. It's not usually true. So, not generally true for quadrilaterals. For example, don't draw a square, draw a rhombus that doesn't have right angles. Something like this. It's almost like you take a square and you squish it, right? All 4 of these could be the same size, right? So this rhombus, a rhombus is all 4 sides are the same. This rhombus is equilateral. All the sides are the same, but it's not equiangular. And then if you wanted to do the opposite, what if all four angles were the same, but the sides aren't all the same? Well, try a rectangle, a long, thin one, right? So all four angles are the same, so this rectangle is equiangular. All four angles are 90, but not equilateral, because not all four sides are exactly the same length. Okay. And then we got one more problem down here. Find the value of x that makes k parallel to L. Okay, well the angles that are here they're on the same side of the transversal, and they're on the outer part, so they're exterior angles. And we know that same side exterior angles that are supplementary give us parallel lines. So in order to make k and L parallel, we want x squared and 3x to be supplementary. So x squared plus 3x is going to be 180. Now to solve this, you're going to you're probably going to want to use the quadratic formula. That's what we practiced earlier. So in order to use the quadratic formula, you want to get the equation into this form, equals 0. Don't forget the equals 0 part. So in order to get it to equal 0, we got to bring the 180 over. And then we've got an a, b, and c. Now a in this case is 1. Right, so a is 1, b is 3, c is negative 180. And hopefully you remember the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now I'm going to do the calculator stuff for this. So here's the calculator. Whoop. And I'm going to input these three things right here, A, B, and C. So in order to do that, A is green on my calculator, so I got to hit the green button first. Oh, actually, no. To store the letters, I hit the number first. Then I hit this button, STO arrow for store. And then I do alpha and then the green A. Right? Anytime I want a green thing, I have to hit the green button first. And then I hit enter. And it tells you, okay, A is stored as 1. So then I'm going to do it with 3 and store it as B. So alpha B. Enter. And then I'm going to do C as negative. Make sure you're using the negative and not the minus. Negative 180. Store as C. And then I want to do this thing. Right? So I need the fraction symbol. It's a lot easier to do it with the fraction symbol than try to get all the parentheses right. So the fraction symbol you can get out of F1. So it's alpha F1. And then numerator over denominator. And then I just need to type in this thing the way it looks. So it's negative b. And then I'll do the plus version first. So plus, and then the square root is in blue right here. So the blue button and then the square root. And then I got b squared, so alpha b. And then this is the x squared button, so it squares what you have. Minus 4, and then the a, and then the c. And then I'll hit down to get to the denominator, all over 2a. And then I'll hit enter, and it'll just tell me what that equals. 12. Great. X equals 12. That's for the plus version. Right? We also need the minus version. The nice thing is I don't have to retype that whole thing. I can just come up here, highlight it, hit enter, and it cuts and pastes. And then I'll just scroll over until I get to that plus, and I'll switch it to a minus, and I'll hit enter. Negative 15 is the other answer. Okay, so then we want to come back and look at the picture and see if this makes sense or not. And if x is 12, then this angle would be 36, and this angle would be 144, and those look about right. So 12 makes sense, but we also have to check if negative 15 makes sense. If you plug in negative 15 squared is going to be 225, and this would be negative 45, which doesn't make sense. So this one is no good. So the answer is going to be x equals 12. Okay, I hope that helps a little bit, and I'll see you guys soon.